So today we're going to start talking a little bit about our first topic. So as you are reading right now to our lecture, our PowerPoint presentation, we're talking about the importance of math. Math is everywhere. So then it's better for you to start liking it and finding the beauty that math can give you in daily things, such as going and buying some groceries, when you're cooking at home and then you need to do the calculations when you're measuring, when you're actually calculating how much money you need to save in order to buy the dress or the new shoes that you want. If you're actually thinking about paying your student loan, it's really critical actually to use math in every single daily basis. So then my invitation, as I mentioned it in the past, is to open the door to math and then try to start seeing the beauty of it. So today we're going to talk a little bit about some problems that I want to go all over, and then some common mistakes that we make when we are solving problems. So then one of the problems that we have in our lecture is about a shampoo. So then we all know, of course, washing your hair is not a rocket science. It's not something that it has a lot of things involved. However, there are different variables that involve not just the brand, not just the ingredients, the components, if it's something that is cruelty-free, that is something that is not being tested in animals, but it also sometimes it affects our pocket, affects our finance. So then it's good to know if what we're getting is a good deal or not. So then some supermarkets, they actually disclose the numbers in a way that you can have a better sense and that you can compare to products. You are actually talking about something in milliliters, and then you have different total milliliters, 300 versus 450, and then you still don't know if it makes sense or not, invest a little bit more. So sometimes they disclose the information so you can compare it, but sometimes you don't have that there. That's not being as transparent and as obvious for consumers. So then an example that we have is with shampoo. So then if you're going in the shampoo and then you are in the supermarket and you want to buy a shampoo, and then you have two different options. So then the first option, as we know, is you can get a shampoo for 225 milliliters. And then this is my friend Achiras. He's gonna be here joining us today. 225 milliliters, and the price of 225 milliliters is $6. Yeah? But on the other hand, you see another shampoo that you're kind of curious about. And then this shampoo is 400 milliliters. And the price is $7.50. Yeah? So then you want to compare which one makes more sense. Because in a way you said, oh, this is cheaper because it's $6. So then that's cheaper. However, this one has more content. So then that's why jumping into that conclusion is not always accurate. We need actually to really crack the numbers to make an informed decision. So then in this point, we actually should compare it and put them in the same way that we were comparing, and comparing by how much money costs 1 milliliter. So then the first question that I ask always my students is like, how can we solve this? And then I have encountered sometimes it's like getting confused, what is dividing what? Is the 6 dividing the 225 or the 225 dividing the 6? So then with this, my biggest advice is trying also to follow your gut. Like sometimes if you do the math and then the number is too large or the number is too little, you actually need to ask yourself, maybe this answer is not accurate. So then I need to review my calculation. So that's the first step, if it makes sense, this answer. And then second one, there are also ways to approach this. So then I'm going to show you something that is really visual and is really easy for you to remember. So I'm going to lay it out with the first one. I have 225 milliliters, and then I'm going to start comparing like this. I have milliliters versus what? Versus dollars. So then on my first row, I'm going to say, if 225 milliliters cost $6, yes, how much money is going to cost me 1 milliliter? And this is the unknown. This is an X or a question mark. Yeah? So a really visual way, as I mentioned it, that I use to solve this type of equations, you can actually use this type of rule, which you look at your equation in a way, and the way of laying it out is that this number one has, his partner is like this X, which is an unknown variable. So then what I'm going to do, I'm going to multiply it by his diagonal. Ooh, This guy is out of ink. Out of ink. Out of ink. So what I'm gonna do, I am going to multiply. And whatever is the result, I am gonna divide it by my fellow neighbor. So in this case, I have 225 is gonna be my neighbor. So then in this case, I'll have 1 times 6 divided by 225. So if I'm gonna lay it out my equation, I'm gonna lay it out my equation like this. I actually wanna put here all my markers so I can lay them out easily for you. Yeah, you. Okay. So I have 1 times 6, yes. 1 times 6 divided 225, yes. What I'm gonna find out, I am gonna find out 1 milliliter, how much money costs 1 milliliter. So then 1 times 6 is 6, and then 225, yes? So now I can solve this, and I can use my calculator. And then if I have my calculator, I calculate it here because I'm filming right now with you guys. I have 0.026, yep, 0.026, yes? Now the question is, you need to ask yourself, what is this answer? Is this answer money? Is this answer just the milliliters? This answer is actually combining both the milliliters and the dollars. And what it's telling me is that 1 milliliter is gonna cost 0.026. So it kind of, in a way, it kind of makes sense because I'm talking about only 1 milliliter, yes? Milliliters, yes? So that's what it costs per milliliter. Now I'm gonna lay it out in a way that I'm gonna have my milliliters and my dollar sign, and I'm gonna do it in a way that I'm gonna compare the same one. So if I have 400 milliliters, and then I know already the price of it because that's the total. They're selling me 400 milliliters and the total is $7.50. So then again, a way of me of comparing is comparing 1 milliliter. How much money is gonna cost me? So then a way of doing that, as I said, remember, I lay it out milliliters versus dollar, the amount of dollar that I'm paying. And then I'm gonna do it with this visual way, which is like I multiply this guy. I don't know how much money costs 1 milliliter. So then that's my unknown variable. That is my X. And then a way of me doing it is that I'm gonna multiply my diagonal. 1 is gonna be multiplying 7.5. And then what is next? I'm gonna divide. So I'm gonna divide it in a way with my neighbor. Who is my neighbor right now? My neighbor is 400. So then again, remember multiplication and then the dollar, then where I multiply and then I'm gonna divide. So then if I'm laying out this correctly, the way that it should be 1 times 7.5 divided by the total of milliliters. So then again, this is one option of doing it. If you can just lay out your equation right away and then you can say, well, it is gonna be $6 divided 225 milliliters, that's okay. I'm just offering another option if you get confused which one is dividing what, because it really changed the answer. So then at this point, I have 1 times 7.5, which the result is 7.5 divided 400. Yes? And then if I'm gonna do this, I'm gonna solve it, and then my total is gonna be 1 milliliter. Remember, that's what I'm finding. So if I'm finding 1 milliliter, that 1 milliliter is gonna cost 0.01, let me actually do it with this guy, so then we have like consistency with colors, 0.018. That is the cost of 1 milliliter. Yes? So then that's milliliter. So now the big question is, what is a better deal? What makes more sense? Does it make more sense to pay 0.026, or does it make sense to pay 0.018? And then you know, of course, the answer, it makes more sense to pay 0.018. And then you think, well, it's just cents. Yes, it could be pennies. It could be like something really minimal. But if you're actually thinking about a business, let's say, for example, you're scaling this up. You're working in the beauty industry, and then you have like a beauty salon. So then imagine going into this type of expenses that every penny is adding. So then you actually need to evaluate if it makes sense or not. On the other hand, you also need to understand that cracking the numbers is going to give you 1 cent of the number, but also later your reasoning is the one that need to kick in, kind of answering the question, are my consumers willing to pay more money? So then if your answer is that no, my market is really sensitive to price, so then it means that you really need to be careful, and then you should go for something cheaper, which in this case is buying the 400 milliliters. But on the other hand, which means in the time, you're just spending a little bit more money because it's gonna be a better deal. But on the other hand, if you know already that your market is a market that is not as sensitive by the price, but is more conscious about other type of variables, such as ingredients, such as brand, then you will probably decide for something 225 milliliters. You will say, I'm getting less, but I am doing it because my consumers are willing to pay more money. So when you're charging your service, you're charging your product, you take that in consideration. So then that's the other point that we need to escalate. Once you crack the numbers, once you have the result, you need to know what I'm gonna do with this. So that's from here. So now moving forward into our example, now we're gonna continue with the relevance of math. So then of course, as we mentioned it already, it's really useful when you're shopping, when you're buying something, when you can compare. But other ways of using it is like even in magic, even in entertainment, probability. There are so many fields that actually use math in different ways. So that's my invitation, is to find the beauty in math and move forward. If you have not a good experience with math, this is a good moment. This is a safe environment to learn and grasp, get a better feel about the concepts. So with the learning outcomes, we want you to be effective communicating, have critical thinking, develop some skills. And those skills are basic skills about math that you can later escalate. And then remember, one thing is having the answer, but then the other thing is giving a meaning to that answer. And that's mostly what is in your hands, trying to understand what is the meaning of the number. Because that's what is going to happen in real life. In real life, you're going to be facing those type of numbers. So then some common symbols that we're going to be here exploring. We're going to be talking about addition, subtraction, multiplication that we're all kind of similar with. Approx, which is like when you're rounding things. So then if you don't have to write down all the number. So we have an approx. It's an approximation, yes. We also have minus, bigger than, greater than, less than, equal, which is kind of saying greater than. So then greater than, less than, and then I always tell my students to remember the greater is the one that is eating the crocodile. But we're gonna talk about this when we're actually approaching probability. We also have the absolute value. So whenever you see some bars and there is a number inside, we're just gonna take the absolute value of this number. We're gonna work with percentage. We're also gonna be working with pi, which has a beautiful way of representing, it's beautiful, pi. We're here not gonna be working with infinitive, but it's good to be aware of this type of symbols that you may even encounter. So I have to admit, when I was studying, I kind of learned the infinitive just kind of in a different way of connotation or writing. But I know that here in the US, you guys write it, you even closer. But the way that I used to do it, it was like more simple. So then those are kind of like some simple basic signs that we're going to be covering here. So moving forward, rounding numbers, that's also important. Sometimes you have a number and tracking the number. It could be hard tracking the numbers. Like it could be, it's not even necessary. So then for you to avoid writing a long number, you can round it. Let me tell you the reasons about rounding. When you're rounding a number, sometimes, as I mentioned, it's not necessary, but the problem of keeping track of a long number is that sometimes you lose accuracy, but not because of the math by itself, but also because of the human error. So then if you're rewriting a number and then you're not paying attention about where is the million, where are the hundreds, then that's actually going to be escalating. So that's a way of saying it. There are some fields, there are some areas that certain type of numbers are not sensitive. So then you rather round those numbers. And let me tell you an example in real life. Like if you're actually designing something, yes? And then you are rounding a number, and then you're rounding a number because it's about centimeters or inches. And then you said it's not a big deal because I'm talking about something that it has a bigger scale, yes? So I'm talking about something that is a structure, is a building, is a bridge, that maybe an inch or a micra is like not gonna make like that difference. But on the other hand, if you have another type of, you represent that mistake of the inch, and you represent that in a manufacturing product, then you're gonna have a mold. Like let's say, for example, I am creating the mold for this lid, for the cap. So then I need to have a system that is gonna come close and it's gonna blow it. And then this needs to be really designed in a way that is really accurate, even with the micras. And it depends also with the machine, it depends with the material, it depends actually even the way that the material is getting heated and is getting cooled down, because it has a contraction. Material is gonna contract and it's gonna create certain type of errors. So then again, having an inch, this already is kind of there. So if you have that in a product like this, that's actually gonna be detrimental. But if we're talking about that inch in a bigger scale, it's not gonna be a big deal. So then that's something just to consider and to keep in mind about rounding. That's the importance of rounding. So then when we have rounding, we have an example, and as I said, I'm really visual. So I kind of want us to see it like here. So then we have 7, 3, so then we have 7, we have 3, then we have 4, 5, and then we have 6 to 1, yes? So then the way it's gonna work out, we're gonna work out just to be really mindful about where things are standing. So then they have a position. So then we have the millions, yes? I have the millions, I have the hundreds, I have the tens, I have the thousands, I have the hundreds, I have the tens, and I have the units, yes? So then whenever you're facing a problem, then they're gonna ask you, round it to the ones, round it to the tens, round it to the hundred, round it to the thousands, then you're moving 1,000, yes? Then they're gonna tell you, round it to the 10,000, then you're moving into the 100,000, and then a million. So then let's see it with an example, which I think is actually gonna be really helpful to grasp this better. So then I'm gonna have these numbers, 7, 4, it's actually 4, 8, 26, yeah. Hope you can see it with the glance. It's kind of like, okay. I'm just gonna try to do it more so you can see better. Okay, there we go. So let's say, for example, as I mentioned before, we have the thousands, hundreds, tens, and units. So then let's say, for example, we are in an environment for whatever we are in the field. It could be architectural, it could be medicine, it could be product design, and then they're asking us, we need this number to be rounded to the tens, yeah? So then if we're rounding the number to the tenth, so remember we have thousands, which is kind of having the number like that, 1,000, rounded to the 100, rounded to the 10, or rounded to the units, yes? So that's basically what it is. The thousands, the 100, the tens, and then the ones. So if they're asking me 200 to the tens, this is the portion that I'm talking about. So then if I have 27, remember we have a rule of rounding that it comes with the 5. 5 is that pivot point, that breaking point. If you have a number that is finished on 5, you're gonna move up. If you have on the other hand a number finishing on 4, what? Achiras, you should be holding this. You're gonna lower down. So then, as I mentioned, it depends. Some fields are going to get affected by this, but some fields are not going to be affected. Are actually going to find more benefits. So then again, with our example, so then we're going to do the tens, and then we're going to do hundreds. So then if we're actually rounding into the tens, we can actually analyze this portion. And in this portion, analyzing it with the 10, we have a 27. Yeah? So then remember, if we look at our rule, if we have 5, we're going to scale it up. So then what will be the number? It will be 30. Because this number is going to get affected. So I'm going to have 4,830. That will be rounding it to the 10th. Yep. Now let's see another example. So I'm just going to erase here. And I'm going to erase this. We're going to keep in mind, we look at the 5, like if it's the number, the last digit. We're looking at the number. And if the number is 5 or higher, we're going to go up. If it's less than 5, we're going down. Down, 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 down. So now here, our example is asking us. Now you did it into the 10th. Now I want to round it into the 100. Boop. So then this is the 10th. Remember, my 100. So then now my 100 is actually also covering because I have 4,827. So then I'm taking that 8. That 8 is coming with me. Yeah, yo. So I'm just analyzing right now 827, not just 27, but 827. And then this is how it's gonna be. It's gonna be in a way that I'm gonna start looking into the back. I said already, this guy is 7, is more than 5. Since it's more than 5, then this guy moves up. So then instead of being 827, it's gonna be 83. Follow me? Yes. Am I done? Not really. That's only the first portion. Yes, as the 10th. Now I'm going into the 100, baby. Going for the 100. So going with the 100, I'm gonna analyze my next friend. My next friend is the 8. So then the 8 is telling me, oh, with this number, 8 and 3. 3 is less than 4, which means I'm going down. So I'm gonna keep it there. So then if I keep it there, I stop it there. So then instead of this 8 going up, which will be 9, it's just gonna stay there in the 8. So then this number, if I'm rounding it up, is gonna be 4,800. If I'm talking about 100. Yes? Awesome. Perfect. If I'm moving right now into my next section, which is actually the thousands, remember? So the next section is to the 100. So with the 100, remember we just analyzed the thousands. I just analyzed this portion, which is the 827. Now since I'm rounding into the thousand, I'm analyzing 4,827. So now I need to include this little dude here, and this means 4 is also going to be included. Yes? So then we're going to start moving. We're going to start moving in a way that we said 4,800, yes, and 27. We can even know already that when we analyze the 100, we were already 480. However, we're going to do it in a way that we can actually go from here to here. 7, up, because it's greater than 5. So remember, equal or greater than 5. So then this means it's 483. Yes? Now we're talking about 8. This is my next friend. I'm talking about I have a 3. 3 is lower than 5. So then I'm keeping it there. Don't scale it, don't go up, don't too fast. So I'm gonna keep it there. And then here I have, remember, 8,000. Now that I'm in the 4,800, because I'm rounding it into the 100 level, I'm gonna jump into the 1,000. So I'm jumping into this little dude here, and I'm gonna look into my friend who is telling me that clue, how I'm gonna round it. That's an 8. 8 is greater than 5, remember? So then I'm going up. So then if I have next a 4, I'm going up, which means 5. So then if I'm 100, I'm rounding it into the thousands, it will be 5,000. And let's say, for example, I don't know, you're doing it in a way that your dad is gonna give you some money, and then your dad is telling you, I'm actually planning on giving you 4,827. And you said, thank you, that's actually really generous, I really appreciate. You can ask, do you think it will be possible to round it to the 1,000? You never know, he may even say yes and you get the 5,000. Hopefully he doesn't just say, no, I'm just rounding it to the unit, or there are ways to make it a run. So you get my point. So this is about rounding. And also we learn about the importance. Remember, it makes sometimes easy, even though we are kind of not carrying big numbers with a lot of digits, because sometimes we are prone to make mistakes, and that is the idea of rounding numbers. Sometimes in some fields, some areas, we want to avoid those mistakes, and then we know that the number is really not going to affect the final outcome. That's actually something that in your hands, that's actually where you keep that in mind. If you're actually in accounting, you will see actually this type of things where people start rounding out things, and then of course at the end, imagine if they keep rounding those numbers, you're going to be off with some money. So then that's the type of things that saying this is not a good field for run, for example. Excellent. So now moving forward, a little bit more about our lecture. Yes, so let's talk now about prime and composite numbers. So then we have prime, and then we have the composite numbers. So then the prime number is the number that it can be divisible for itself. So then 1 is either. We don't give a category. And I have to admit, which is kind of interesting, when I was studying, when I was younger, it was actually considered a prime number. So then that's how things change and evolve. You know, we revisit some theories that we have. So then right now it's not even considered because it's actually even included. So when we're talking about the composite numbers, we're talking about some numbers that they have multiple factors. So then they have more than 2, which is 1 and itself. Basic example, like as I mentioned, 2, which is kind of a beautiful number. 2 is a prime number because it can only be divisible. I can divide it only by 1 and 2, and it's even, which is kind of nice, which is par. So you can actually learn that. So moving forward, so of course, when you're learning about this, you actually need to know about, if it's numbered, and then for example, I have 4, yes. 4 is not a prime number because I have more numbers that I can multiply. So then it's like 2 times 2, So then for 4, what are the factors for 4? So then for 4, if I'm dividing it, I have 2. I can divide it. 1 times 2, 2, 2 times 2 is 4. So then it's 2 to the power of 2 or 2 times 2. So then the numbers, the factors, I can write it down here. Don't get stressed, we're gonna get there. So with the factors, I'm gonna have the number by itself, which is 4. I'm gonna have 1, and I have an additional number, the 2. Another example of finding factors. So then factors is good